This is the third part of the lesson for Level 3 in Unit 2. And the topic is modeling addition and subtraction of rational numbers on the number line, Part 2. Make sure you have the focus notes in front of you. They should look like this. If you don't have access to them, you can click on this link right here and see a copy of them and then organize your notes the same way as you listen to the lesson. So the essential question we are attempting to answer today is, how do we model addition and subtraction of rational numbers with unlike denominators on the number line? And the reason we want to be able to do that on the number line is because it's much easier to model difficult problems, which tend to be the ones with unlike denominators. If we can do it on the number line, it's easier to visualize. So let's start with visuals. Let's start with a picture. Consider the addition equation 1/2 plus 4/5. 1/2 and 4/5 are broken up into different sized pieces. If I look at the denominator, 1/2 means that my whole is broken up into 2 pieces. And for 4/5, if I look at the denominator, it's 5. So the whole is broken into 1, 2, 3, 4, 5 pieces. That's a problem if I want to add these together because I have different size pieces. You can see it very easily here on the circles. And if you look at the number line, you'll see what the problem is. Look here, 1/2. Here's my whole from 0 to 1, and it's broken into 2 pieces. So for 1/2, I would shade from 0 to 1, right? 1/2. And here's also a whole for 4/5, broken into 5 pieces since it's 5/5. And then I shade in 1, 2, 3, 4. How do I add these together? Because over here, 1/2, the piece is much larger than the fifths, right? They're not the same size piece, so I cannot easily add them together. In order to be able to do that, I need to have a common denominator. So that's why we need to be able to do this, to have a common denominator, so that we can have the same size piece, and then easily be able to add these two fractions together. But that means we need to rewrite each fraction with that common denominator. So let's look at example 1. It's the same question we were just looking at on the previous slide, 1/2 plus 4/5. But since we have different denominators, denominator 2 and denominator 5, first, step 1 is to find the common denominator. Recall from our previous lesson that the first step to finding the common denominator is to list the multiples of 2 and list the multiples of 5. So think about it. You may not know how many multiples you need to list out, but you might start by listing like 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, and 2 times 6 is 12. And like maybe you think, well, that's probably enough. And then you start listing the multiples of 5. Here, you're probably going to list less because as soon as you see the common one, you can stop. So here, 1 times 5 is 5, and then 2 times 5 is 10, and I'm going to stop there because right away I see that 2 also has 10 as a multiple. So that's my smallest multiple they have in common. So my least common denominator of 2 and 5 is 10. Now remember, the whole purpose of doing this is we want to take 1/2 and 4/5 and rewrite them with a common denominator so they have the same size pieces to add them on the number line. So instead of 1/2, we want to rewrite this as an equivalent fraction with a denominator of 10. And for 4/5, we want to rewrite it with an equivalently with also a denominator of 10. So in order to do that, remember you have to think about what number times 2 will equal 10. And so here 2 times 5 equals 10. What I do to the denominator, I have to do to the numerator to keep it equivalent. So I also multiply the numerator by 5. 1 times 5 is 5. So 1/2 written with a denominator of 10 is 5/10. Similarly, I look at 4/5 and I think about 5 times what number gives me 10, and it's 5 times 2 equals 10. So what do I do to the denominator? I do to the numerator. 4 times 2 equals 8. So 4/5 is equivalent to 8/10. And I want you to come back up here to the top of the example and rewrite this. So instead of 1/2 plus 4/5, you're going to write it as 5/10 plus 8/10. Since 1/2 was rewritten as 5/10 and 4/5 was rewritten as 8/10. Now this problem looks very familiar and we're ready to model it on the number line. So the first number is 5/10. That's where I start. I'm going to move by adding 8/10. So I start at 5/10 on the number line and I count to the right 8/10. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10. And I stop there. And this is my answer where I ended. And if you count from 0, or even from here, if you know this is 5/10, you can go 5, 6, 7, 8, 9, 10, 11, 12, 13. So the number where we ended was 13/10. So 1/2 plus 4/5 equals 13/10. Let's look at a second example. 3/4 plus a negative 2/3. Again, 4 and 3 are different denominators. So first, I have to rewrite them with a common denominator. The first step of finding a common denominator is to list out some of the multiples. So multiples of 4, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Maybe you just go a couple more, like 4 times 4 is 16. And then now you list the multiples of 3. 3 times 1 is 3, 3 times 2 is 6. Still don't have one in common, so I keep going. 3 times 3 is 9. And then I stop here. 3 times 4 is 12. And I see that, oh, I have one of those. 12 is also a multiple of 4. So that's my least common multiple. So the least common denominator of 3 and 4 is 12. Again, remember the purpose of finding the least common denominator is to rewrite 3/4 and negative 2/3 with the common denominator of 12. In order to do that, for 3/4, we consider 4 times what number equals 12. And of course it's 3, so 4 times 3 equals 12. What I do to the denominator, I have to do to the numerator to keep it equivalent. So 3 times 3 equals 9. So 3/4 is equivalent to 9/12. And then I have negative 2/3. I look at the denominator. I think what number times the denominator will give me 12. And that's 4. 3 times 4 is 12. So what I do to the denominator, I do to the numerator. And now be careful here because you do have a negative number. This is negative 2 times 4. A negative times a positive is a negative. So negative 2 times 4 is negative 8. Do not forget the negative because that will change the direction when you're moving on the number line. So here are my equivalent fractions, and I want you to rewrite this now. Instead of 3/4, I want you to write it over here as 9/12 plus, and instead of negative 2/3, please rewrite it as the equivalent fraction negative 8/12. Now if I look at this, they have the same denominator, so I'm ready to model them on the number line. The first number, 9/12, is where I start, and then I'm going to add a negative 8/12. So that's how much I'm going to move. I start at 9/12, and if I'm adding a negative, I go to the left. 1, 2, 3, 4, 5, 12, 6, 12, 7, 12, 8 12s, and I stop there. So if you look at this number here, you can count from 0, 1 12th. So the answer where you end is 1/12. So 3/4 plus negative 2/3 equals 1/12. Last of all, let's look at an example with a whole number in it. Now to begin with, the process is the same. I know that some of you have been taught in elementary school that anytime you see a whole number and a fraction, what's called a mixed number, that you automatically need to convert it to an improper fraction. There are times where that is necessary, and if you want to do that, you're welcome to do it. You will not see me using that method in this example. But if you convert it to an improper fraction, you'll get the same answer as what I'm going to do right now. But first, I'm going to start by finding the common denominator. Because I see here negative 6/9 minus a negative 1/6, I have two denominators, 9 and 6. So before I can model this on the number line, I need a common denominator. You begin by listing the multiples of each of the denominators. So you might go 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, right? List out 5 or 6 of them, and then begin listing the multiples of 9 until you find one in common with the multiples of 6. So 1 times 9 is 9, 2 times 9 is 18, and hey, I can stop there because 18 is also a multiple of 6. That is the least common denominator of 6 and 9, 18. And now I need to rewrite both of these numbers with the common denominator. So let's take a look at this. If I look at the first number, negative 6/9, 9 times what number equals 18? That's 2. 9 times 2 is 18. What I do to the denominator, I do to the numerator to keep it equivalent. And be careful, here you're multiplying negative 6 times 2, and negative 6 times a positive 2 is a negative 12. And then when you have a whole number, you're not changing the amount of the whole numbers. It's always going to be negative 1. The only thing that's changing is how much the whole is broken up into, right? So instead of a whole broken up into 6 pieces here, right, we're going to have a whole broken up into 18 pieces. So you don't need to change anything with the whole number. You can simply write it over here, negative 1, and then rewrite the 1/6 using the new denominator. So again, I think about 6 times some number equals 18, and that's 3. 6 times 3 is 18. So I do the same to the numerator. 1 times 3 is 3. And my new equivalent fraction is negative 1 and 3/18. Make sure you rewrite it up here, and then we're ready to model. So we start at the first number, negative 12/18, and then we're going to take away a negative 1 and 3/18. Minus a negative means we will move to the right. And if you want to think about it this way, a whole number means like I have to move 1 and 3/18. That means a whole is worth 18 spaces since it's broken into 18. So if I start here at negative 12/18 and move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 spaces, that's moving a whole number 18/18, the whole number 1, and 3, and then I continue moving the fraction part, 1, 2, 3/18. And this number right here is 9/18, which I can simplify. Remember, the numerator and the denominator can both be divided by 9. 9 divided by 1 is 1. And 18 divided by 9 is 2. So this number is 9/18, or 1/2. So that's my final answer.